In this problem, we're given a rational function and we're asked to draw the horizontal asymptote and write its equation below the graph. To remind you the rules, shortcut rules for finding the equation for a horizontal asymptote, if there is one, look over here. You compare the degree of the expression in the numerator to the degree of the expression in the denominator. So for example, the expression in the numerator is negative 2x. Its degree, if you remember, the degree of a polynomial is the highest exponent. So for my problem, my degree is 1. And then I compare that with the degree of the expression in the denominator. In the denominator, my expression is x plus 1. Its degree is its highest exponent, which in this case is 1. Now there's three cases. The degree of the expression on top, which I labeled t here, can be bigger than the degree of the expression on the bottom, which I've labeled b. That's not the case here because they're both 1. The second case is if the top is smaller than the bottom, meaning if the degree on top was smaller than the degree on the bottom, you'd have y equals 0 as the equation for the horizontal asymptote. What we have is the third case. The degree on top is equal to the degree on the bottom. My top degree is 1. The degree of the expression in the denominator, the bottom, is 1. So the top is equal to the bottom. So what you need to do is you need to form the ratio of the leading coefficients of the two expressions. I call it the thumb rule. It's kind of comical because you can actually put your thumb over the problem and actually see the answer if you know where to put your thumb. So at any rate, what you do is you look at the leading coefficient, which is always the coefficient on the expression with the highest exponent. We already said that this is, well, there is really only one term up here, so this is the term with the highest exponent because there's only one, and its coefficient is negative 2. So that's going to be the numerator of my answer. The expression in the denominator here, x plus 1, the x has the highest degree because it's degree 1. The plus 1 is the second term of the denominator, and it's degree 0. So I need to look at the coefficient of this guy, and there is no coefficient written, so it's implied to be the number 1. So what I do is I form that ratio, which means to take negative 2 and divide by 1, and that would be the equation of the horizontal asymptote. So my answer is y equals negative 2 over 1. So I call it the thumb rule for the following reasons. Rather than looking at it this way, what you could do if the terms are in descending order, and that's what you have to pay attention to, is these have to be in descending order. If they're in descending order, then the leading coefficient is always the one in front. So you actually see the answer right here. If you let me put the 1 as the coefficient on the x here, the answer to the question is actually y equals negative 2, which is sitting right here. So the reason I call it the thumb rule is if I could actually put my thumb over the part of the problem that doesn't count, if this is a really poor version of my thumb, but it would cover up all this part of the problem, and what would be left is the equation y equals negative 2, which is the answer to the question. So it's important that you realize what y equals negative 2 is and what its significance is. What this means is on the graph, as the graph goes way to the left and way to the right, it levels off to be this horizontal line, y equals negative 2, and that's what we're asked to graph here. So to graph that horizontal line, that's sort of like a wall that the graph approaches but doesn't cross, what you do is you click on the draw command here, pick any point that would be on the line y equals negative 2, and then click and hold the mouse button down, move either left or right, and make it look horizontal like so. Pick any other point on that horizontal line y equals negative 2 and let go of the mouse button, and you've got yourself the graph of the horizontal line y equals negative 2. Now if I could scroll way to the right and way to the left, you'd see that the graph gets lower and lower and lower. Its y values get really small, and it would approach y equals negative 2 but never cross. Same thing to the left. If you were to scroll way to the left, it would get infinitely close to that horizontal line y equals negative 2. Don't forget to click down here and type in y equals negative 2 as the answer. Now on the second part of the problem, it's a completely different concept. We're asked to find the vertical asymptote. The procedure for finding the vertical asymptote is completely different, but the idea is the same, that somehow there's a wall that exists on the graph for which the graph doesn't cross but becomes infinitely close to. You can tell by looking at the graph that the graph looks like it goes vertical right here. So if I had to guess, it's somewhere around negative 1, negative 1.5. So to find out the exact value for which the graph seems to go steeply up and steeply downward, I'm going to do this procedure where you simply take the denominator, write it down, set it equal to 0, and solve. So over here I've got the solution to that problem written down here. In fact, we don't even really need to see the rest, but if you look down here on vertical asymptotes, it says to find the equation for a vertical asymptote, you set the denominator, which is x plus 1. equal to 0, and you solve that by simply subtracting 1 to both sides. If you did that, subtracting 1 on the left-hand side would yield x. If you subtracted 1 on the right-hand side, you'd have 0. Subtract 1 is negative 1. So you get the solution x equals negative 1, but it's not just the solution of this equation. It's actually the equation for a line that we call vertical asymptote. So I'm going to go back here and I'm going to go down and type in x equals negative 1 so I don't forget. That's the equation for a vertical line. A vertical line, x equals negative 1, looks just like that, a line that goes up and down straight through negative 1. So to graph it, make sure that you've selected the draw line command. Pick any point that would be on that vertical line x equals negative 1. Click and hold the mouse button down, either go up or down. Pick any second point on that vertical line and let go. And you've got yourself the graph of the vertical line x equals negative 1. You can almost imagine this graph getting infinitely close but not touching that vertical wall.